All right. The boss decides this. All of that was yesterday's. The boss decides to hire one more employee. And I'm going to turn this little example into fast food for just a moment. Who works in fast food? Fast food, where do you work, Jake? Taco Bell. If Taco Bell has 50 orders in 10 minutes, are there going to be some mistakes? Yep, there's going to be some mistakes. At Taco Bell, if 50 orders come through in 10 minutes, we're trying not to, but we're going to have some mistakes. Would there be less mistakes if they hired another competent person? So now we got one more person working. 50 orders in 10 minutes. Will there be less mistakes because everybody now can take a little more time? Shake your head, does that make sense? Same with this product. They're going to hire one more employee because these things are made with an employee and a machine. It needs a skilled person. They're going to hire one more person. So now the machines are going to get built a little more accurate to standards. And what's going to happen, because it's a little more accurate, the standard deviation is going to go down to 50. Meaning more of the machines are going to be very close to what they should be. There's not going to be as many that are really good and not as many that are tending towards bad. We need to find what percent this changes. A new Z-score. What is our important number to the company? 880, because anything below 880 they have to pay a refund. All that has changed is now we're doing a Z-score of 50. Would you please take 880 minus 1,000 divided by 50? Shout, because I don't have a calculator. And can we go to the nearest hundredths on this chart? Surround to the hardness. 2 point. Huh? 40? Negative 2.4. Would you go to your chart and find out what percent that is? Did I find it right? 0.0082. Make that into a percent. Be careful, please. That's 0.82%. That's less than 1%. That's less than 1% now. By hiring another employee, less than 1% are going to fail. So, the number that fail, please take this number times the 10,000 they sell. Please take this times 10,000. And does that find that 82 of them fail? Take that, you need to refund these people, take that times 500. Help, I don't have it. How many? 41,000. Using the 125,000, how much money do they save by doing another employee? There you go. All right. So that's something they're thinking about. Let's hire one more person, just like at Taco Bell. If we have one more competent person, it's going to be people going to have a little more time to make the sandwich, and it's going to be more accurate. Less of them will be bad. The company has one more option that they're thinking about. Because you see, they're tired of giving refunds. That's expensive. All right. So here's what they're thinking of. Instead of an employee, they're thinking of getting a new machine, which costs $600,000. These are made by a machine and people working together. Now we got a better, up-to-date machine. Our product is going to be more accurate, more better. That was good English, and I recorded that too. That's going to lower the standard deviation to 45. A better machine means your products are going to be closer to what they should be. Less of them will be really good, less of them will be really bad. Another Z-score. 880 is our important number. Anything below that, we got to pay. All this changes is your help. I don't have a calculator up here. And we got negative 2.66. Let's round it to 6.7, negative 2.67. Find it on our chart, please. I think I found the right one, did I? 0.0038, which is a percentage of 0.38 of 38 hundredths, well less than 1%. Less than 1% now with this new machine would fail. Please take this decimal times 10,000. A lot of you can do it in your head. 38 machines fail. Please take it times 500 to see what it costs them. I don't have a calculator up here, help. 14,000. How much do they save? And let's use it from this original 125. Do they save 111,000? Yes? Here's the final question. How many years would it take this machine to pay for itself? It costs 600,000. It saves 111,000 each year. You got to do a mathematical computation between those two numbers. Subtracting would be a bad idea because that would mean that they take about 480,000 years for it to pay off. Multiplying would be bad. We have to do those two numbers and do what? Divide them, and we get about how many years till it pays for itself? About 5.4 years, it'll pay for itself. Cool. All right, goodbye to the people at home.